Alright, in this video we are going to practice graphing the tangent function, and we're going to be dealing with changes in the period and phase shifts as we go. Oh, look, on the next problem we're also going to have a reflection, so we'll be dealing with that as well. Real quick, let's take a glance back one more time and remember the basic look of the tangent function. Now focus your eyes on the yellow part over here because this is one period of the tangent function. The green is showing a second period of the tangent function. So one period of the tangent function starts at the midline and ends at the midline, and there's a vertical asymptote in the middle. So the graph rises and approaches the asymptote, and then it picks up from down below and rises to the midline. That's what one period of the tangent function looks like. Alright, one period of the tangent function has a length of pi unless there's some sort of a stretch or compression that's happening. Alright, with that in mind, let's take a look at problem number 5. Okay, now there's one thing I'm noticing right away. I'm seeing that I have a b value coming as well as some type of a phase shift. But please understand, pi over 2 is not the phase shift. I repeat, pi over 2 is not the phase shift. You have to factor this 2 out before you can read the phase shift. So that's what I'm going to do. I'm going to rewrite this. I'm going to factor the 2 out. So if I pull the 2 outside of parentheses, okay, so to do that you need to divide by 2. And if I divide pi over 2 by 2, the way you divide by 2 is really you just wind up putting it in the denominator. Okay, so this is going to be pi over 4. So I will have x plus pi over 4. If that bothered you, the way I just put this in the denominator like that, here's a way that might help you to think about it. I need to do pi over 2 divided by 2, right? So that's pi over 2 divided by 2. But when you divide and you're dealing with fractions, you have to multiply by the reciprocal. So this would be the same thing as pi over 2 times 1/2. And then hopefully you can see that if you multiply straight across, you get pi over 4. Now for me, it's quicker just to understand that when you divide a fraction by a number, you just put that number joins the denominator. Okay, now you have 2 ways to think about it. You're welcome. Okay, so I pulled the 2 out. So, and then I have the rest of it. Okay, so see how I have parentheses inside of parentheses? That's what you should always have when you have a b value and a phase shift. So then fine, I have my tangent and my 2 and my y equals. So rewrite the function when you have a b value and a phase shift before you try to read the phase shift. Okay, fine. So this is my a value, which helps me draw the graph later. This is my b value, which is going to help me with the period. So let's go ahead and do that now. So the period is always the normal period divided by the b value. Okay, so in this case, and don't forget the normal period of tangent is pi, so that's why I'm doing that. So it's going to be pi divided by the b value, which is 2. So the period is simply pi over 2. I will deal with the x-intercepts and the vertical asymptotes at the end after I've graphed it. The phase shift. The phase shift is given to us by this h value, but it's the opposite of the way it looks, so it will actually be negative pi over 4, which means that it is to the left. Okay, so as I begin to do my graph, normally the tangent function starts at 0. But if there's a phase shift, then it's not going to start at 0 anymore. It's going to start at the phase shift. So since we have a phase shift of pi over 4 to the left, Normally I put 0 right in the middle because that's where tangent starts. But because of the phase shift, I'm going to start at negative pi over 4. All right, because that's where the first point of the tangent is actually going to be. Okay, so the first point of my tangent is going to be right here. Now, every one of these marks represents 1/4 of the period. So I'm going to just count my way over 4 spaces. So 1, 2, 3, 4. So this is where this period should end. But I need these values. So it would be helpful to figure out, okay, what do I need to add on to here to get these values? So it's going to be 1/4 of the period, like I said. So the period is pi over 2. So the question is, what is 1/4 of the period? All right, I'll erase this later. So if the period is pi over 2, then a quarter period is going to be 1/4 of pi over 2. All right, and so that's going to be pi over 8. So pi over 8 is a quarter period. So every one of these marks should be increasing by pi over 8. So in other words, if I take pi over 4 and I add pi over 8, I should get the next value. And I should be able to do that over and over again. Okay, but if I want to do negative pi over 4 plus pi over 8, don't you want to have like denominators to do that? So wouldn't I multiply by 2, all right, in the top and the bottom in order to get like denominators? All right, so that's going to make this negative 2 pi over 8. So fine. So what I have is negative 2 pi over 8 plus 1 pi over 8. So isn't that going to be negative 1 pi over 8? So that's just going to be negative 1 pi over 8. Okay, that's going to be this mark right here. Now, if I add pi over 8 again, see, I'm just going to keep adding pi over 8. So negative 1 pi over 8 plus 1 pi over 8, those are going to cancel out, and I'll just get 0. Now, if I add pi over 8 again, all right, 0 plus pi over 8, that's just pi over 8. All right, if I add pi over 8 again, all right, pi over 8 plus pi over 8 is 2 pi over 8. All right, I put these values here just in case I had to do any reducing. I didn't want the numbers to be in my way. All right, but now I'm going to go back and put the numbers actually on the number line. And as it turns out, there wasn't much reducing that had to be done. So as we found, this is negative pi over 8. And this was 0. And this was pi over 8. Now 2 pi over 8 reduces down to pi over 4. Okay, you must reduce. You can't leave values lying around like 2 pi over 8. You must reduce. All right, so these x values will give me the right-hand period of this tangent function. Now I'm going to also need the left-hand period, so I might as well keep going because we need to draw 2 periods of the tangent function. So if I go over 1, 2, 3, 4, this is where the left side of the tangent function should begin. But I can continue the pattern that I started. All right, I've already got pi over 8s happening. So going to the left, I should be subtracting pi over 8. All right, so if I start at negative 2 and I subtract, if I do minus 1 pi over 8, basically, shouldn't that be negative 3 pi over 8? And won't it just keep going as I subtract another pi over 8? Won't it be negative 4 pi over 8 and negative 5 pi over 8 and negative 6 pi over 8? Alright, starting at negative 2 pi over 8, right in the middle, negative 3, negative 4, negative 5, and negative 6. I'm just going down by 1 pi over 8. Alright, to me this is the fastest way to do it. Now, I put them down below instead of putting them on the number line because I knew that some of them would probably have to be reduced. Negative 3 pi over 8 can't be reduced. But negative 4 pi over 8 is the same thing as negative pi over 2. So that must be reduced. You can't leave it. Negative 5 pi over 8 can't be reduced. Negative 6 pi over 8 is negative 3 pi over 4. Okay, so these 9. These 9 x values must be labeled on your x-axis. Mandatory. Okay, I'm going to go ahead and erase this now that I've done it. And I'm going to erase this too. Okay, now would be a good time to put in the y-axis. All right, we know that over here we're going to have 1 period. You know what, maybe I should put in my vertical asymptotes first. So we know we're going to have vertical asymptotes right in the middle of each period. Now would probably be a good time to do that, so the y-axis won't distract us. So right in the middle of this period should be a vertical asymptote. Okay, and we should show a vertical asymptote as a dotted line. Okay, now I'm going to try to copy off myself here. Shouldn't you show up already selected? Why are you so annoying? I should have another vertical asymptote over here in the middle of this period. Alright, so I'm set up for 2 periods. Now would be a good time to talk about the y-axis. Now it's going to be a little bit weird because the y-axis is right here. The y-axis is always at 0, of course. But I also have an asymptote there. So somehow I'm going to try to do both. And so how am I going to do that? I think I will go back and try to make this one solid. Did I not get it? I'm going to turn this one solid again. And then I'll put another one on top of it that's dotted. Alright, but the point is I have a vertical asymptote and the y-axis kind of in the same place. Alright, but I'm going to try to show them both. But I think I'll make this one yellow so that it will show up hopefully on top. Alright, this is just my OCD taking over my body. Okay, so there you go. Just, do your best with that. It's rare that the y-axis and the vertical asymptote are the same thing. And I know you can't do exactly what I did as far as the colors, but do your best. Now, I'm going to go ahead and draw the graph. So, on that y-axis, I need to go back and deal with the a value. So the a value is 2. So I'm going to be very careful to go ahead and mark that on my y-axis. Okay, so I'm going to go ahead and put 2 right here. And I'll go down an equal distance and put -2. Alright, that a value is going to show up as I do my graph. And here's where it shows up. So we know that the tangent function is always increasing. So it's going to be increasing from the midline as it approaches the asymptote. But halfway over, it should be at the a value of 2. So I'm going to make sure that as I draw my graph, I pass it through that point. Okay, similarly on the right hand side, again it's rising, so it starts from down low and I'm rising to the midline, but halfway over it should be at the A value, the negative A value. So now I'm going to go ahead and rise, but I'm going to make sure I pass through that point. So this is what one period of the tangent function looks like. Now I'm going to do the same thing on the left side, always rising, but halfway, making sure I'm at the A value. And again, coming from below, but halfway over, making sure I'm at that A value. So I'm just going to make sure that I pass through that point. Alright, so there you have it, 2 periods of your tangent function. Alright, so now as we talk about the x-intercepts only happen once each period, at the beginning, and then it doesn't happen again until the end. So I like to just start with my first positive x-intercept, which in this case is pi over 4, and I write that down. So I start with x-intercept of pi over 4, and then because it happens once every period, I add multiples of the period. So the period is pi over 2, so I'm going to say n pi over 2. And I'll just indicate that n is an integer. Alright, it could be a positive number like 1, 2, 3, or a negative number like -1, -2, or -3. Okay, similarly with the vertical asymptotes. I don't have any positive vertical asymptotes. The vertical asymptotes also only happen once per period. And but we have one of them is at 0. So imagine that I said, so I could have x equals 0. Alright, that would be the equation of a vertical line. But then, if I wanted to add multiples of the period, because it occurs once every period, since the period is pi over 2, I would be adding n pi over 2, where n is an integer. Okay, now, so this is an equation for the vertical asymptote, all the vertical asymptotes. However, you know, technically we really don't need the 0. 0 plus n pi over 2 is just n pi over 2. So if you wanted to be more sophisticated about it, you wouldn't really put the 0. You would just put x equals n pi over 2. 0 is not needed. But usually there'd be a number there and you would need it. But that's going to do it for problem number 5. And I'm going to try to slide straight into problem number 6. Alright, I'm trying to do 2 problems on each video. Okay. Now watch out, in addition to everything that happened on the last problem, this one has a reflection over the x-axis. Okay, so let's rewrite this. Again, we have to pull out the 1/2. When you have a b value and a phase shift that's about to happen, you need to take that b value and factor it outside of parentheses. So I'm going to take this 1/2, I'm going to put it outside of parentheses. Now I need to figure out what this is. So to take it out, I need to divide. So I need to do pi over 3 divided by 1/2. So remember, pi over 3 divided by 1/2. That's the same thing as pi over 3 times 2 over 1. You multiply by the reciprocal. So that's going to be 2 pi over 3. Alright, so that's what's going to go right here, 2 pi over 3. Alright, and then we will have the rest of it. See how I have parentheses inside of parentheses? That's what you're going to have whenever you have a b value and a phase shift. Alright, let me just erase this stuff. Might get in my way later. Okay. So we have a reflection, so watch out for that. This graph is going to be upside down. But this is our A value. We'll need that later as well when we do the graph. We have our B value. And we have our H. We have an H value. So the period is going to be affected by the B value. So we know that the period is always going to be the normal period divided by the B value. So in this case, that means we have pi divided by 1/2. Okay, and so to divide, you multiply by the reciprocal. So this is going to be 2 pi, right? Because the reciprocal of 1/2 is 2. So that's it. So the period is going to be 2 pi, right? We will deal with the x-intercepts and vertical asymptotes at the end after we've done the graph. The phase shift, there is a phase shift. It's the h value, but it's the opposite direction of what it looks like right here. So the phase shift is going to be a negative 2 pi over 3 because it is to the left. Okay, so that should be enough information for us to start the graph. Now, remember that whereas a normal tangent function starts at 0, all right, and then goes to the right and to the left, because of the phase shift, it's not going to start at 0. So instead of putting 0 in the middle of the number line, by the way, make a number line like this. Instead of putting 0 in the middle, I am going to put the phase shift in the middle, because that's where the first point should be. So negative 2 pi over 3 will be the number that I put in the middle of my graph right here. Okay, so I'm going to put negative 2 pi over 3 in the middle of my graph. And so I know there's no vertical shift, there's no vertical translation. So that point that normally is at 0 has now shifted over to the left to this value of negative 2 pi over 3. So I can safely go ahead and graph that point, knowing that this is where the tangent function begins. The tangent function ends on the midline as well, and since every one of these marks represents 1/4 of the period, I should be able to just count over 4. 1, 2, 3, 4. And this is where the period should end. Now, I need these numbers though. I need to number the x-axis. Now, I just mentioned that every one of these marks is 1/4 of the period over. So, I need to know what is 1/4 of the period. Okay, well, so it's 1/4 of the period. So the period was 2 pi. So as I calculate 1/4 of the period, that's going to be 1/4 of 2 pi. You know, in other words, 2 pi over 4, which equals pi over 2. Okay? So every one of these marks should be increasing by pi over 2. So that's why I'm going to add pi over 2 over and over again. So I need to take negative 2 pi over 3 and I need to add pi over 2 to it to find out what the next mark is going to be. But of course we need like denominators, yeah? Yeah. So to get like denominators, I'm seeing denominator of 6 coming. So I'm going to multiply this. Whoops. I'm going to multiply this by 2. Okay. And I'm going to multiply this by 3. Alright, now I'm also going to do it up here so I can use it over and over again. So multiplying by 3. Okay, that's going to make this 3 pi over 6. Okay, so what I have now is, and that's going to make this negative 4 pi over 6. So I have negative 4 pi over 6 plus 3 pi over 6. Guess what that is? Well, negative 4 plus 3 is negative 1. So that means this next mark should be at negative 1 pi over 6. Can I erase this stuff now? Alright, so my next mark is going to be at negative 1 pi over 6, or simply negative pi over 6. That's this mark right here. Now, the good news is the rest of these are going to be easy because I've already done the work once, so I can just repeat. I don't need any more like denominators. So if I want to keep adding pi over 2, then I'm just going to keep adding 3 pi over 6. Okay, so if I have negative 1 and I add 3, that's going to be positive 2. So this will be 2 pi over 6. If I add 3 more, then that's going to be 5 pi over 6. If I add 3 more, that's going to be 8 pi over 6. Now, I'm doing them down here instead of on the number line because I know that some of these will reduce. Negative pi over 6 can't reduce, so I'll just go ahead and throw that up there. Negative pi over 6. 2 pi over 6 reduces 2 pi over 3. 5 pi over 6 does not reduce, so we'll have 5 pi over 6. 8 pi over 6 reduces to 4 pi over 3. So 4 pi over 3. So these are the x values that will give me 1 period of the tangent function. But I need to do 2 periods, so I'd like to continue this pattern to the left. So again, using the pattern I already have set up, I can just, instead of adding, I can just subtract as I go to the left. Alright, so this next mark over. So I'm going down by 3 now. So if I go down by 3 from negative 4, that's going to put me at negative 7 pi over 6. If I go down 3 more, that's going to be negative 10 pi over 6. Alright, these are pretty close together. If I go down by 3 again, that's going to be negative 13 pi over 6. You know what? I should have marked where I'm going to stop. 1 period. I'm going to go 4 of these. So 1, 2, 3, 4. So that's my target. If I go down by 3 again, that's going to be negative 16 pi over 6. Okay, and again, I put these down here out of the way, knowing that some of them will have to be reduced. Negative 7 pi over 6 cannot be reduced, so I'm just going to leave it what it is. Alright, it's getting crowded in here. Negative 10 pi over 6 can be reduced. That's negative 5 pi over 3. Okay, negative 13 pi over 6 can't be reduced. Negative 16 pi over 6 can reduce to negative 8 pi over 3. Alright, so these 9 x values need to be labeled on your x-axis. And I think that the method I just showed you is the most efficient way to achieve that. Okay, now I'm going to erase all this work now because it's in my way. Now remember that right in the middle of each period there should be a vertical asymptote. So I'm going to put a vertical asymptote over here, and I'm going to also put one over here. Alright, so there should be a vertical asymptote over here. Okay, and that's going to be a dotted line. Alright, as soon as my computer stops thinking. Alright, now my computer's running a little slow today, so it makes my video run a little slow. Sorry about that. And I'll do the same thing over here. Did I do it? Okay, see the delay? See what I'm dealing with, people? Okay, and again, I'm going to make that a dotted line. Alright, now I'm ready to go. Now, before I just go ahead and draw my two periods of the tangent function, it's time to put the y-axis in here. Alright, now where should the y-axis go? And notice how I put the y-axis in last. You know, after I label the x-axis, after I put in the vertical asymptotes, that's when I'm going to put the y-axis in. Here I have negative pi over 6 and positive pi over 3. So guess what? The y-axis is going to go in between those two numbers. So just put the y-axis in between there somewhere. Technically it should be a little bit closer to pi over 6. But, you know, as a teacher, we're only going to be but so picky. Okay, so there's my y-axis. Now on my y-axis I'm going to mark any a value that I have to deal with. So my a value is negative 1/4. Okay, so I'm thinking about 1/4. So I'm on my y-axis, I'm going to mark 1/4 above and below. Okay, now I don't want it to be teeny tiny, so I'm really going to, you know, I kind of put this a value at the same place every time, and I just label it different things. So this is 1/4. Man, this is getting crowded down here. But this mark down here is negative 1/4. I'm going to try to squeeze it in as best I can. Okay, but that's at 1/4. This is at negative 1/4. Okay, that comes into play as I do my graph. So the tangent function is always increasing. However, all right, so as you can see, so looking at the tangent function from left to right, it's rising, and then it jumps down here, but it's always rising, and then it jumps down here and it's always rising. Okay, so the tangent function is always rising. However, this is not a normal tangent function. Oh no, this has a negative sign in front, so we have to be careful because this is a reflection over the x-axis. For that reason, the main thing that's going to change is instead of rising, the tangent function is going to be decreasing everywhere. Everything I draw from left to right is going to be falling, always falling. So just keep that in mind. So starting with this point like I normally, oh man, what is that? That's not what I meant to do. Can I control Z that? Okay, I didn't want my y-axis to be pink right now. Okay, so starting from this midline, like I normally do, but instead of rising, I'm going to be falling this time. Now remember, halfway to the vertical asymptote, it should be at the a value. So don't be distracted by the y-axis, right? Ignore the y-axis. Halfway between the midline and the vertical asymptote is where we have a mark, you know, negative pi over 6. So it should, but here's my negative 1/4 on the y-axis. So it's got to be falling because it's a reflection over the x-axis. but as it falls, it should pass through this point at the a value halfway. So it's going to fall, passing through that a value and approaching the asymptote. So as I pick up the rest on the other side of the vertical asymptote, I need to jump up high because I need to be falling towards the midline. Halfway over, though, I should be at this a value, so I'm going to go ahead and put a dot there. And so as I fall, I'm going to make sure that I pass through that point. Whoa. Alright, so this is what one period of the tangent function should look like. So now similarly on the other side. Alright, starting from this point on the far left. Always falling now because of the reflection over the x-axis, but again I need this extra point that's at this a value of -1/4, so it should fall through that point as it goes. Alright, now it should jump up to the sky so it can again fall its way back towards the midline. Again, I need this extra point halfway over at this a value, so I'm going to go ahead and put a nice dot right there. So as I fall, I'm going to make sure that I pass through that point. So that is what two periods of the tangent function should look like. Alright, all 9 of these x values must be labeled with everything reduced, and these two y values at a minimum representing your a values need to be labeled on your y-axis. Okay, now the x-intercepts only occur once per cycle, once per period. So I'm just going to pick my only positive x-intercept, which is 4 pi over 3. I'm going to start with that. So I'll put 4 pi over 3. Now because they only happen once per period, I can add multiples of the period. So in this case the period is 2 pi, so I'm going to put plus 2 pi n. And if I let n be an integer, that includes positive values and negative values. So it'll get the x-intercepts going to the left and to the right. Similarly with the vertical asymptote, my only positive vertical asymptote is here at pi over 3. So I'm going to start with that one. And again, they only occur once per period. So I'm going to again add multiples of the period. So 2 pi n again. And I will again indicate that n is an integer. So that's going to do it for number 6, and that is the end of this video. Alright, I will see you on the next video for problem number 7 and number 8. So this is more good practice similar to this very difficult problem that we just did for number 6. So, and in fact, if you want to, go ahead and do number 7 by yourself and then switch to the next video and see how you did.